Yes, so today we are going to discuss about one of the very important and simplest applications of stack. So that is known as parenthesis matching, or it is also known as balanced parenthesis. So let's understand this particular problem and write down the algorithm and do the time complexity analysis, and let's see how it works. So before starting this particular lecture, so if you are new to this particular my channel, so please subscribe to this particular channel, share with your friends, also press the bell icon so that you can get the videos whenever new video come to the channel. Okay, so now let's focus on this particular application of the stack. So parenthesis matching or balanced parenthesis, what does that definition or what does that means understanding? It is telling, so given an expression, we need to see whether the balance parentheses are in balance form. What does that means? For every opening bracket, so there is a closing bracket. So that's what we need to do by using stack. So let's take an example and see whether this particular example is a balanced one or not a balanced one. So definition says what? For every starting parenthesis, there must be a ending parenthesis or there must be a closing parenthesis. So that's what the problem. So in this example, if you will think about this one, for this one, so there exists a closing parenthesis. If we take this one as the opening parenthesis, so then there exists a closing parenthesis, right? So if there exists a opening, so there exists a closing parenthesis, right? So this particular expression, is known as a balanced parenthesis. So this expression is already in the balanced parenthesis. But the question is how to match or how to find out if there is a opening bracket, there must be a closed bracket using stack. But before going for the algorithm and all the details, let's take another example and see whether this particular parenthesis is matched or not. Let's take another expression. Suppose this is another question. Suppose I will take the same example, a plus b star c minus d, and now this is another question. If somebody asks you whether this is a balanced parenthesis, answer is yes. The answer is yes, because for this opening bracket, so there is a closing bracket. For this opening bracket there is a closing bracket. For this opening bracket there is a closing bracket. For this opening bracket there is a closing bracket, right? So that's why this is a balanced parenthesis. Yes, this is a balanced parenthesis. Okay. So given another expression, suppose the expression is given a plus b into c minus d. Suppose this expression is given. So that means but in this case, so suppose this expression is, can you tell me whether this is a balanced parenthesis? Answer is no. Why? Because this is balanced with this one, but this is balanced with this one, but this is not in balanced form. So this particular bracket is not in balanced form. Okay. So if I will take similar example, a plus b, okay, a plus b into c minus d. So this is also not in balance. Why? Because this is a extra bracket present in this particular expression. Now the question is how can I do the same thing using this particular stack, right? How to solve this one. So let's try to understand this particular problem, and let's try to understand the approach how we should solve this, then only we can solve it. Okay, so let's understand it. Okay, let's understand it. So let's take this example. So I'll erase all these things and let's take this example, the first example that we have taken. So first example we have taken, let's understand clearly. So how we will do this? Okay, okay. So this is the example, and we know that this is a balanced parenthesis example. Yes, this is a balanced parenthesis. But how can we write a algorithm or how to write a program for this to check by using stack? That's very important. By using stack, how can we use an algorithm or a program to check whether this given expression, any expression, I am taking this example, but for any expression, so it is going to give answer output as yes, it is a balanced parenthesis or not. So that's what the answer will be. But let's understand. So I will take a stack. Okay. So what is the concept? I will tell you the concept. After that we will see. if any left parenthesis is coming, then I will push into the stack. So that's the concept. If right parenthesis is coming, then I will pop the left parenthesis and don't push the right parenthesis, because that is a match, right? So don't push the right parenthesis, just pop. Okay, so the concept I am writing here, okay, just writing here. If a left parenthesis, just push into the stack. If right parenthesis, then pop the top element, pop the top and check. It should be left. Whenever you are popping it, it should be a left parenthesis, because that's how it will be a match, right? So that you will check and you will continue. You will continue till this particular point. At last, you will see that stack is empty. At last, stack is empty. At last, you will check that stack is empty. This is the last step. You will keep on doing in the loop. That means you will keep on doing in the loop, but that's okay. We will write down the algorithm and all. But let's understand. So I will scan this particular expression from left to right. So that's what I will do it. Okay, I will start with the first character. So I will push it into the stack. So that's what the first step. Is it a left or right parenthesis? No. Then I will ignore it. Okay, because we are interested only the left and right parenthesis, and the problem tells we are checking only the parenthesis. So that's why if anything else coming apart from this particular bracket, so then we will ignore that one. So in this particular case, I will ignore A, then I will ignore plus, then I will ignore B, then I will see right is coming. So once right is coming, what I will do, I will go to the stack, I will check whether there exists a left bracket in the top of the stack. If yes, then I will pop it, because I got a match, right? So I got a match, so that's why I will pop it. So now I got a match. Now I will scan, then star will come. Do I need to do anything? No, I don't need to do anything, because star is, I can ignore it, because I am interested only two things, right? One is left parenthesis, one is right parenthesis. Now a left parenthesis is coming, so what I will do, I will push into the stack, right? So now C is there, so I will ignore it. Minus is there, I will ignore it. D is there, I will ignore it. Now a right parenthesis is coming, so now I will check whether a left parenthesis exists in this particular stack or not. Okay, so after that I will check it and I will delete this one if a left parenthesis is doing. Then I got a match. So now I am done with this particular thing. So there is there are no elements are there. Now the stack is also empty. If the stack is empty, so then we can say it is a balanced parenthesis. Okay, balanced parenthesis. So that's the algorithm. Okay, for all symbol, okay, scan from left to right, or scan from left to right. If left parenthesis push, if right parenthesis pop the top, and it should be C. Check that it should be left parenthesis. If it is not left parenthesis, then you can exit from here. Okay, so that's what the concept. So let's take another simple example that we have discussed and see how this particular stack is behaving. Okay, how this particular stack is behaving. So let's take this similar example. Suppose A plus B plus C minus D, some example, this one. This is a given expression. So now I will take a stack here. Okay, so now the question is check whether this particular parenthesis is matched or not. If you check, yes, it is a matching parenthesis. By looking into this, we can say yes, it is a matching parenthesis. But the question is whether this is a matching parenthesis or not. So by using this one, we will check. Okay, by using this particular stack. So let's do that. Okay, so now what I will do, if a left parenthesis is coming, so this is a left parenthesis, so I will just push, because left parenthesis means push, right? So that's what the concept says. Here another left parenthesis is coming, what I need to do? I need to push, because there is only one operation for left parenthesis. Now I will scan A, I don't need to do anything. Now I will scan plus, don't need to do anything. B, don't need to do anything. Right parenthesis means I will check whether at the top of the stack there exists a left parenthesis, because this is the right parenthesis, so I need to check left parenthesis. So if there exists a left parenthesis, then pop that one. That's for the operation. Then pop this one. That means I am removing this element. So now the stack structure is like this. So now I will continue. Plus is there, so no operations needs to be done. Now a left parenthesis is coming. So what I need to do for left parenthesis? I need to push into the stack, right? So that's what I need to do. Now I will come to C. C I don't need to do anything because this is not a parenthesis at all. Minus I don't need to do anything. D I don't need to do anything. If it is a right parenthesis is coming, then what I need to do? I need to pop this particular left parenthesis from the stack. That means now stack is like this. No, now I am done with this. Now another parenthesis is coming. Now I will also pop this. Now the stack is empty. Since the stack is empty at last, so this is a balanced parenthesis. Okay, so that's what the conclusion. That means this example, whatever we have taken, this is also a balanced parenthesis. So now let's take another example which is not a balanced parenthesis. Let's take a simpler example. Suppose like this. Okay, suppose this is there. Suppose this is the thing. So this is, by looking into this particular expression, you can see that this is not a balanced parenthesis, right? So this is not a balanced parenthesis. But the question is how to validate using stack, using the same concept that we have discussed just now. So what will happen? Left parenthesis means we will push into the stack. If we will push into the stack, another left parenthesis, I will just push it into the stack. So that's what if we do. If left parenthesis is coming, then there exists a right parenthesis. So there will be a right parenthesis means it will check whether stack contain a left parenthesis. Yes, it contains. If yes, then we'll pop it, right? So we did the pop. So now we are done with this. Then now plus is coming. We don't need to do anything. Left parenthesis, push it into the stack. C nothing to do. Minus nothing to do. D nothing to do. Then a right parenthesis is coming. Then what you will do? We will pop this particular left parenthesis. So now we are done with this particular scan. Now we will check whether the stack is empty. Answer is no, stack is not empty because it contains a left parenthesis. So then we will say that this particular given expression is not in sync or not a parenthesis matching. Okay, so that is all about the concept. So in the next video we will be discussing about the complete algorithm along with its time complexity and the implementation approach. Also we will discuss in the next slide. But in this particular video, I will give an example. I will ask a question actually. I will ask a question. Just write down in the comment section. You can write down. So given expression, okay. So given expression. So this expression is giving. Okay. This expression is giving. Okay. Some expression. So this is, I am just writing the bracket. So write this one. I could have written like this, right? This one, the formula means I could have written like this, right? So that's how I am writing. So suppose this is so this is a given parenthesis. Okay, so this is a given parenthesis. Okay, so what is my question? So this is a given parenthesis. Okay, some expression is given with similar kind of parenthesis, because in this example also we are not interested in the only we are interested in left and right parenthesis, right? So that's why I made this particular example simpler. My question is what is the maximum number of at any point what is the maximum number of left parenthesis present in this stack. So that is the question. So if this is the given expression and you are using the same formula that we have discussed, so at what point what will be the any point, that could be any point, but what will be the maximum number of parentheses that are present in the stack? So that is the question. Just answer in the comment section. I will validate and I can reply you back. Just answer in the comment section. How many maximum number of left parenthesis, how many maximum number of elements or maximum number of left parentheses can be present at any particular time? Okay, so that number you need to give. How many? 2, 3 or 5, something like that. So that you need to give. Okay, so that's all for today's lecture. So we are going to discuss, as I told you, different algorithm for algorithm and approach and the time complexity in the next video. And thank you for watching, and please don't forget to subscribe and click the bell icon and share with your friends as well.